We present the HandTech project, an interactive educational platform for children using hand tracking technology. Traditional museums and the educational materials remain passive. Children observe but do not interact. Our project solved this problem by transforming learning into an active and intuitive process. Using Unity technology, we create a digital environment where children can directly interact with objects. Disassemble them, rotate them, select parts and receive information in real time. Our approach combines education, interactive design and modern technology. We are creating not just a digital museum, but a new form of learning where children learn through action. The project potential extends to educational institutions, museums, exhibition spaces and a digital learning platform.
On this platform, I have experienced such a good experience. So I could see all the details in the object and unwrap all the details and choose one specific detail and read all the information about this detail that I chose. So that's a good experience to have. So I'm good to experience it. One of the first people, one of the first person in this platform.
Бұл платформа жастарға, балаларға өте қызықтырып жасалатындай жасалыпты.
My name is Dias and I was responsible for the 3D modeling part of this project. For this project, I created a set of 3D models representing early technologies using Autodesk Maya. The goal was to create models that were visually accurate and optimized for a real interaction in Unity. So in a total, I have developed about 10 different models. Each models had to look realistic enough to be easily used in an interactive system. Each object has been divided into separate parts, allowing users to interact with individual components inside in the Unity application. After completing the work on the models, I exported them in FBX format to ensure with Unity.
The platform is built on the Unity game engine. It is responsible for the entire visual components of the project's 3D models, animations, and the interactions with objects. Within the system, each model consists of individual parts with which the user can interact. An information display system is also implemented. When the user selected a part, a brief, child-friendly description appears on the screen. The system tracks the user's actions and updates the state of the objects in real time, making interaction smooth and convenient. We also developed the interface. We added gesture prompts, a small camera window, and animations that help better understand what's happening. Thus, Unity is responsible for the entire user experience and makes learning visually clearly and interactive.
The second important part of the project is the gesture recognition system. We use the MediaPipe technology, which allows the camera to track the user's hand movements in real time. The system detects the position of fingers and uses it to recognize gestures. For example, spreading the fingers means disassembling the object. Bringing them together means assembling it. Moving the hand means rotating the model. And select a specific part with a finger allows you to highlight it. All movements are processed instantly, so the control feels natural and does not require training. The camera captures the user's actions and the system immediately transmits this data to Unity, where it's converted into actions on the screen. This ensures fast response and a smooth operation without delays. As a result, the user can control the system simply by using hand gestures without the need for a mouse or keyboard.
Hello, my name is Ismkhan Tolonay and I was responsible for design direction of this project. The entire design was developed using Figma. My main goal was to create a clear, well-structured and visually engaging interface. That's why the design focused on simple navigation and bright visuals tailored to our target audience. The first screen is the main menu, where users can select a language and easily enter the system. On the second screen, the content is divided into 4 historical eras. Each era contains several 3D models, allowing users to explore the materials in a structured and intuitive way. On the third screen, the selected model is displayed interactively using hand tracking technology. Users can explore the model in detail and receive additional information by selecting specific elements. Overall, we are not just presenting a visual design, but delivering a fully throughout interactive educational experience.